Welcome to the Teja Statistics. Today we are learning about the probability. Probability is the measurement of chance. The probability is always lies between 0 to 1. So we have to know some definitions and the terminology in the probability, which is very important for business statistics. Experiment. Any work to solve in real life is called an experiment. Next, trial. The repetition of an experiment is called a trial. The coin is tossed 5 times. Here, the 5 is a trial. Next, outcome. What is the outcome? The result of an experiment is known as outcome. Example, in writing of an examination, we may get the two results, that is pass or fail. Here, the two events, that is pass or fail, are outcomes. Next, types of events: simple event, compound event, mutually exclusive events, non-mutually exclusive events, collectively exhaustive, equally likely events, independent events, dependent events, and complementary events we have to learn. Yeah, simple event. The probability of happening of non-happening of a single event is considered as a simple event. When we are selecting two black coins from a box containing 10 white and 5 black coins. Next, compound events. It refers to the joint occurrence of two or three events. It is also called as composite events. A box containing 5 white balls, 3 black balls, and 8 red balls. When we draw 2 white balls in it first draw and 2 balls in second draw, 5 balls in third draw is compound events. Okay, mutually exclusive events. When two events cannot occur simultaneously in a single trial, then such events are called mutually exclusive events or in composite events. When a single coin is tossed, either head or a tail can be turned up. Both cannot become at the same time. So one stops the another. So this type of events are called mutually exclusive events. Next, definition of non-mutually exclusive events. When two events can occur simultaneously in a single trial, then such events are said to be homogeneous non-mutually exclusive events. For example, from a pack of cards, drawing a red card and drawing a queen card are two events. These two events can occur simultaneously while drawing a red and queen cards from the pack of card. Next, fifth definition, that is collectively exhaustive events. These events are events whose totally contains all the potential outcomes of a random experiment. So it is a result of an experiment. Okay, next, equally likely events. Events are said to be or considered as equally likely events when the probability of occurrence of all the events are equal. Suppose if you toss a coin, then the probability of getting head is 1 by 2 and the probability of getting tail is also be the 1 by 2. Next, independent events. Two or more events, two or more events are considered as independent events when the outcomes of an event does not influences it is not influenced by the another event, then that type of events are said to be independent events. Example, when a student has to appear in commerce examination and business statistic examination, his marks obtained in commerce his marks obtained in a business statistics examination, marks obtained in commerce is independent of the marks obtained in business statistics. Next, definition, dependent events. Dependent events are events in which the occurrence of non-commerce non-occurrence of one event in any one of trial influence the probability of occurrence of another event in another trial. For example, when a card is drawn from a pack of cards is not replaced, then this changes the probability of occurrence of the second card. Here the probability of occurrence of the second event is dependent on the occurrence of the first event. Next, complementary events. Two events are said to be complementary events if they are mutually exclusive and collectively exhaustive. When a coin is tossed, getting a head or tail, mutually exclusive events and collectively exhaustive events. Thus, if we get the tail, then head is considered as a complementary event. P of A bar is equals to 1 minus P of A. This is very important complementary event. Next, we have some definitions of probability. Probability is a quantitative measure of uncertain events. It helps in determining the chances of the occurrence of an event. Classical definition. The classical or priori approaches assumes that all the outcomes of random experiment are mutually exclusive and equally likely. According to the priori approach in a random experiment, when there are m favorable cases to a favorable, then event A occurs. If m has to be the possible cases, then the favorable event A does not occur. The probability of getting a favorable cases P of A can be calculated as P of A is equals to number of favorable cases divided by total number of or all possible outcomes of that experiment. Next, importance of classical theory. Here, this probability is always lies between 0 to 1. The sum of the probabilities of an event is always a complement, that is P of A plus P of A bar is equals to 1. Next, the sum of the probability of success and failure is always 1. Probability of occurrence for any event has 3 chances. In case of certain event, in case of impossible event, in case of uncertain event. So that's why this probability is always lies between 0 to 1. Let's see one more example over here. 2 dice are rolled. Find the probability of getting the number as 6 if sum of the digits on dice. So 2 dice are rolled. How many number of outcomes we will get? Here we are going to get 36 outcomes. 1 comma 1, 1 comma 2 and so on, 1 comma 6, 2 comma 1, 2 comma 2 and so on, 2 comma 6 and 3 comma 1, 4 comma 1, 5 comma 1, 6 comma 1, 6 comma 6, 36. Let E be the event of getting the sum on dice as 6. So how many number of favorable cases, how many number of total number of cases are here? You can see. So here n equals to 36, m equals to, if you add 1 comma 5 you will get the number 6. Similarly 2 comma 4, 3 comma 3, 4 comma 2, 5 comma 1. So here how many number of events are there? Favorable cases are there, that is 5. So 5 divided by 36. The probability approximately you may get 0.13. That means 13% of chance is occurred. Next, we are going to discuss the set theory. Okay, the collection of finite or infinite number of objects with the same common property is called set, or else we can define the collection of well-defined objects is called a set. Okay, a set is usually denoted by the capital letters. Lowercase letters are used to signify the elements of the set. Universal set, any set which includes all the other sets defined is called universal set. It is denoted by mu. Okay, null set is very important definition. Null set, a set with no elements is called or empty or null set. It is denoted by pi. Okay, the power set, if X is any set, then its power set is consists of family of all its possible subsets. The power set is denoted by rho of x or 2 to the power of x, such that x less than or equals to x. So this can be written in roster form also. You can see some examples. Addition theory of probability. Probability of A union B is equals to probability of A plus probability of B when there is no common value, that is vanishes. Mutually exclusive. In case of non-mutually exclusive events, then P of A union B is equals to P of A plus P of B minus P of A intersection B, as you can see in the graph also. Okay, yeah, next in the next session we will see some more problems on this probability and set theory. Thank you.